Passport to Advanced Math Lesson 8 is dealing with Standard 11, which is understanding the relationship between zeros and factors of polynomials and to use the knowledge to sketch graphs. Well, first thing we want to talk about, what are zeros? And we're going to start by reminding you what an x-intercept is. This is the point where the graph crosses the x-axis. The zero of a function is basically an x-intercept. It is the value, x value, that makes the function equal to 0, meaning it's the x-intercept of the function. The term, right, with the highest degree of the function determines the number of possible zeros, meaning if I have f of x equals 2x to the third plus 6x minus 3, if I look at the highest exponent or degree of the function, it tells me I can have up to 3 real zeros. Okay? Now to find them, right, we can factor the polynomial and then set each factor equal to 0 and solve that equation, just like solving a quadratic by factoring. Now remember, you can always just graph it on your calculator and then look for where the graph crosses the x-axis. That's just another way. Now you could also use zeros to write the polynomial. So if I told you, asked you, write the polynomial if the zeros are x equals 3, x equals negative 5, x equals negative 1. What I'm basically doing is taking x equals 3 and I'm going to set it equal to 0 by subtracting 3. So x minus 3 equals 0. I'm going to do the same thing with x equals negative 5. Add 5, x plus 5 equals 0. Then I'm going to take x equals negative 1, add 1, x plus 1 equals 0. And now, these are basically the three factors. So it would be x minus 3 times x plus 5 times x plus 1. I could then take these and multiply them all out if the answers were in that form. Okay? So let's take a look at some examples here. Which of the following is a value of r for which r plus 2 times r minus 3 is equal to 0? It's basically what are the two zeros of the function. So if I take r plus 2 out, set it equal to 0, r minus 3 out, set it equal to 0, and I go ahead and subtract 2, r equals negative 2, add 3, r equals 3, 6 is not a 0, 0, no, negative 2 is, right? And I'll check the other ones. Negative 3 is not. Negative 6 is not. So negative 2 is the only 0 as an answer choice. Now, the next one. In the xy plane, the graph of a function f has the x-intercepts negative 3, negative 1, and 1. So remember, x-intercepts are your zeros. So when I write this down and I set each of these equal to 0, I would get x plus 3 equals 0, x plus 1 equals 0, x minus 1 equals 0. So right away I know this function would be x plus 3 times x plus 1 times x minus 1, which ends up being, so we got x plus 3 right here, x plus 1, x minus 1, letter C. Remember, multiplication is commutative, so it doesn't matter which way you multiply the three factors. Now this is a tricky one, right? So they give you a graph and they ask the function f of x equals x to the third minus x squared minus x minus 4 is graphed in the xy plane above. If k is a constant such that f of x such that the equation f of x equals k has three real solutions, which of the following could be a value of k? Now, what you have to understand is we know f of x equals k is no different than y equals k. So what they're basically asking for is what horizontal line goes through the function 3 times. So if I read this as y equals 2, y equals 0, y equals negative 2, and y equals negative 3, remember, when you have y equals a number, that is the graph of a horizontal line, right? So that when I go up here, If I graph y equals 2, that's going to be the horizontal line that goes through 2 on the y-axis. Does that have 3 real solutions? No, there's only one intersection point there. If I do y equals 0, that only crosses the graph one time. When I do y equals -2, that only crosses the graph one time. But when I do y equals -3, right, there's one intersection, 2 intersections, 3 intersections. So y equals -3, or letter D, would be your answer. Okay, so again, that's an easy problem, but if you don't understand, what they're asking, it makes it difficult. The next one, f of x equals x plus 3 times x minus k. So the function f is defined above. If k is a positive integer, which of the following could represent the graph of y equals f of x in the xy plane? So right away, when I look here, I know if I take x plus 3 equal to 0, one of my x-intercepts is -3. So when I look at this graph has an x-intercept of -3. That does not. This does not. And if I look here, here's my x-axis. That does. So right now, just by looking at the 0 or the x-intercept, I know my choice could be A or D. How do I determine the rest of it? Well, is this function going to open up or down? And remember, I always look at, right, the A value. What is multiplying? If A is positive, it opens up. If A is negative, it opens down. Since your A is +1, this opens up, so it has to be letter D. Okay?